In this video, I am going to talk about traverse computations. There are various computations and adjustments required for a closed traverse. Some of these include determining the latitudes and departures and their respective algebraic sums, calculating the total error of closure, balancing the survey, determining the adjusted position of each traverse station, and computing the area in some instances, dividing a survey tract into smaller parts. But before going to the proper lesson on traverse computation, let me give you some introduction about traverse. The measured angles or directions of closed traverses are always um readily investigated before leaving. I mean, you must always investigate the measurements of angles and directions before you leave your field. Now, the linear measurements, even though repeated, may cause some error. So even if you keep on measuring a certain point, 2 points repeatedly, so even though you keep on repeating the same procedure, it is most likely to, I mean, likely to commit some error. So you must also check this kind of uh, observations. There are so many different
All right.
procedures that you can use to compute and adjust traverses, and it varies from your a very simple method or what you call elementary methods to a more advanced techniques based on the method of meron tayong tinatawag na least squares. Okay, but in this video I am just going to introduce to you the different terminologies that we usually use in traverse, like departures, latitudes, angular misclosures, linear error of closures. So this will be all part of our lesson today or in this video. The line of latitude is its projection on the reference meridian or a north-south line. So if you have this meridian, reference meridian, say, if you have a reference meridian here, so it says here that the line of latitude is its projection on the reference meridian or a north south line. So this is your north south line. So therefore, this is your line of latitude. Now, latitudes are sometimes referred to as the northings or southings, and latitudes of line with northerly bearing are designated as north or positive. So those in the southerly direction are designated as south or negative. On the other hand, the departure of line is its projection on the reference parallel or an east-west line. So departures are east or positive. For line having westerly bearing are west or negative. So if you have a point, all right, so your line AB is the direction of your traverse. So it comes from A going to B. Now, the latitude of this line is the north north south line of your meridian. So let's say this one. If you have this line, so this is your latitude. Okay. And the horizontal is the departure. And the bearing of this line, which is this this one, uh, usually we denote this as theta. Okay, this is your bearing of the line, and this is the theta uh, of your. It is the angle, the direction of your line, right? So how are you going to get the formula? What is the formula for departure of a line? So the formula for the departure of a line is simply getting its. And by the way, this AB, usually you have the distance, right? The distance AB. So this is your formula for the latitude. Okay. So next we have the departure. Now for your departure, departure is the sign. So sine. So instead of cosine, it's sine of A. And then you change this to your departure. And then distance. So departure is equals to the distance times the sine. The sine of A. All right. So here you go. All right. So how about the tangent? Okay. Now the tangent of A is simply equal to, or angle A, you can say angle A is, or you can also say that it's tangent. So tangent A is equal to departure over latitude. So these are the basic information about traverse. Okay, so what are the signs of your latitude and departure? So usually, um, the latitudes and departure, it goes with a quadrant, no? So let's draw a quadrant here. Okay, so this is in the first quadrant. This is quadrant one. So in here, in the first quadrant, always remember that when your latitude is on the north, it means it is positive. So in the first quadrant, your latitude is positive. So your latitude is positive on the first quadrant, and your departure is positive too, because it's on the east side. So it means it's also positive. Now, in the second quadrant, your latitude is negative because you are on the southern part, but your departure is positive. Okay. Now, on the third quadrant, your latitude is negative and your departure is negative too. Okay. On the fourth quadrant, your latitude here is positive and your departure is negative. So this is how um, you recognize the sign of your latitude and departure. Okay, so this is the basic. Okay, so don't ever forget this. Okay, so let's say, for example, let's try an example. Okay, let's say you have a bearing line of AB. So let's say bearing line AB. Okay, so this is A, and of course, you have to put your reference meridian. So your reference meridian here is, because you cannot plot your line if you don't have a reference meridian. Okay, so this is your A and this is your B. So let's say the distance between A and B is, let's say 70 meters. And your angle or the bearing is, say, northeast. Uh, this is northeast, right? So let's say the bearing is 60. Okay, this is 60 degrees. Now, if you want to get the latitude and departure of your line using the manual way of computation, so you can go and do the sine cosine function or the trigonometric function of your uh, figure. So in this case, so manually you can compute your departure of line AB. So that's how you write. So you just simply multiply the distance, which is 70 meters, times the sine of 60 degrees. Okay, so departure of line AB is equal to, you can get your calculator and try to press your calculator. Okay, so you can, I will show you also the shortcut. Okay, sine 60 degrees equals and then times 70. Okay, so this is 60.622. Okay, so this is your departure. And then your latitude, AB, is equals to 70 and then cosine of 60 degrees. Or latitude AB is equals to, get your calculator, you press the cosine and then 60 degrees. Okay, that is zero point 0.5 times 70. Okay, you get 35. All right, now if it's only one line, it's very easy. But when you have so many lines to do the latitude and departure, you need a bit of speed. No, uh, we can we can do that by means of this technique in the calculator. So let's try this. To get the latitude, no, let's try to compute the latitude using the calculator. Okay, so shift rectangular. Can you see this rec? We need the rectangular, and then you enter the distance, which is 70, then comma. So your comma is here. And then enter the angle, which is 60 degrees. Enter. Okay, so your latitude is 35. Okay, so your latitude is 35 and it's positive. Okay, so it's also 35. So shift and then look for the rect. Okay, shift, rect, and then enter your distance. Okay, enter the distance and then comma. Yes, and the comma and then the angle. Okay, so and then you close the parenthesis, you enter, that will be your uh, latitude. And of course your departure is 60.622. So here you can just press the arrow, press the arrow that shows y. So sometimes you will really get confused because you will wonder why. Given the accompanying tabulation are the observed data for a closed traverse. Determine the following quantities: latitudes and departures of each course, linear error of closure, bearing of sight of error, and precision of the measurement. Okay, so let's compute for the latitude and then our departure. We will use the calculator which I have. So, para mabilis tayo. So, shift rec and then press 233, 233.10, comma, and then enter your azimuth. So, 122 degrees, 30 minutes. Now, here, I will show you how to do the sign. Oh, sorry. So, this one is 233.10 and then shift this one 122 degrees, then 30 minutes. All right. So we have to write down the 125, 125 point 24 245. Okay, 245. All right. Now, the sign of your latitude is negative because 122 is on the second quadrant. So you have to consider the sign. And of course, your departure is uh, 196.595, and that's positive. Okay, so 196.595. 595. Okay, now we go to the next one, the BC. So your BC is shift rec and then type the length 242.05, comma, okay, and then 85 degrees, 15 minutes. So you can see this is in the first quadrant, so they will be all positive. So this is 80 point 20.044. Okay. So 20.044. And then the next one is, the Y is 241.218, 219. Okay, 241.219. Okay. Okay, so this is the final output of our latitude and departure computation. We need to add all the positive latitudes and the negative latitudes, as well as the departures, positive departures and negative departures. And then we are going to get the algebraic sum of latitudes and departures, and named it as CL, or closure in latitude. And for the departure, it's closure in departure. After getting the closure in latitude and closure in departure, we are going to compute the linear error of closure, where linear error of closure is equals to the square root of CD squared plus CL squared. So substituting the values, we got LEC equal to 1.525, and tangent theta is departure over latitude. So we get this final answer for our angle. Okay. And so finally, we are about to get the relative precision of our traverse. So we have LEC divided by the perimeter, or the total length of your traverse. So RP is equals to 1.525 divided by the total distance of our traverse is 1424.14. And if we want to get the relative precision, same as usual, which I have taught you before, you have to divide the numerator by itself and the denominator by its numerator, so that you will get the form of a relative precision, which is 1 over the denominator. So you round it off to the nearest, to one significant figure. So you get 1 over 900. So this will be all for the traverse computation. This will be included in your midterm exam.